Good morning, dear students. In the yesterday's class, we discussed about two problems in dot product as well as cross product, but we didn't complete those problems. So in this class, we can complete those problems. See that? So this problem has 3 points, so that we need to identify R bar AB dot R bar AC, similarly angle between R bar AB and R bar AC. So the length of projection of R bar AB on R bar AC and the vector projection of R bar AB on R bar AC. So first we need to identify R bar AB dot R bar AC. So I told you the formula for that. So what are the formulas? R bar AB is equal to small RB bar minus small RA bar. So similarly, R bar AC is equal to small RC bar minus small RA bar. So you can see here, so R bar AB is equal to small RB bar minus small RA bar, and R bar AC is equal to small RC bar minus small RA bar. So how can you able to obtain this RA bar, RB bar and RC bar? So how can you able to obtain this, as well as how RAB will become small RB bar minus RA bar? You can see those things. So let us take a rectangular coordinate system. So this is the x-axis, y-axis and z-axis. So the rectangular 3D coordinate system. Actually, YZ is in the plane of screen. So whatever the screen you are seeing, those YZ are in that plane. So x-axis is towards to you. Actually, it was perpendicular to the plane what you are seeing. So that means it was towards to you. Actually, it is unable to draw that line. So what I am doing here is I just incline with some angle so that you can draw that x-axis. Actually, it is not possible to draw x-axis. So for our convenience, I was able to make some inclination for that, so that it was x-axis. So x-axis actually it was towards to you. So x-axis, y-axis and z-axis. So generally this will be the rectangular 3D coordinate system, which contains 3 axes. So in this, now you have 3 points. So point A. So as described in the problem, so point A is what the point which contains 2 pi minus 1. So let us assume that point is available at that place. So now we have to draw a vector from origin to point A. So we have to draw a vector from origin to A, which represents small RA. So that means it also can be called as point vector. What is it? This also can be called as point vector. So that is small RA. So now let us take the point B. So similarly, we need to identify the point vector for the B. So let us assume that was small r B bar. So similarly, point C. So in the same manner, we need to identify a vector from origin to C, which can be called as point vector of C. So this is the point vector of C, can be called as RC. So now what we need exactly, and we need to identify exactly RAB bar as well as RAC bar. So that means RAB bar is the vector that is from the point A to B. So RAB bar means the vector that is from the point A to B. So RAC bar means the vector that is from point A to C. So here, so this is the vector. So it was coming from A and terminates at B, and that vector can be called as RAB bar. So now we need to identify RAC. So the vector that is starting from A and ended at C can be called as RAC. So now we need to identify RAB and RAC by using the small vectors small RA bar, small RB bar and small RC bar. So we have the formulas for this. Capital RAB is equal to small rb minus small ra. How that formula came, you can see here. So let us take the origin. So let us assume the vector coming from origin to the point A is RA bar. So let us assume it was in this way. And thereafter the point B and the vector that is coming from origin to B is RB bar, as we know. So now we need to identify the vector R AB bar, that is from point A to point B. So now we need to identify this vector R AB bar. So how can we able to identify this vector? So as we know, R bar AB is equal to small RB bar minus small RA bar. How this formula came? So let us say the R AB bar is coming from A to B. So what is the another way to reach the B from A? So what is the another way? We have to go from A and we have to terminate at origin. Thereafter we have to start from origin and we have to terminate at B. So we can go in this way. So let us see what will happen. So now we went from A to origin. So see here, the RA bar vector is coming from origin to A, but the direction is A to origin. So the RA bar is opposite direction to the path it was going from A to 0. So which is opposite direction. So for RA it was minus. Next, in which way we have to go to reach B? So we have to go from 0 to B. So in this way we have to go. So it is in similar direction of RB bar. So that RB bar has plus sign. Okay. So how we can able to identify the signs here? So the actual path is from A to B. So that is direct path. So what is the another path? We have to start from A and we have to terminate at Z, and thereafter we have to start from 0 and thereafter we need to terminate at B. So in this way, if you go from A to 0, R bar A, smaller A bar is in opposite direction and smaller B bar is in similar direction. So small RB will have positive sign and small RA will have negative sign. So RAB is equal to plus RB bar minus RA bar. So similarly RAC also. So RAC is equal to small RC bar minus RA bar. So how can I able to represent this RA bar, RB bar, RC bar? Why? Because we need to identify RAB as well as RAC. So how can I able to represent those? We can see. So if you want to represent small RA, so let us take the point A. So what is the point A? 2, 5, minus 1. So we are taking in rectangular coordinate system. So what are the unit vectors in the rectangular coordinate system? X bar, AY bar and AZ bar. So what is the x component here? In the x place it was 2, in the y place it was 5, in the z place it was minus 1. So x component is 2, y component is 5 and z component is minus 1. So the vector is 2 into ax bar plus 5 into ay bar plus minus az bar. So let us see that how we can be able to write those. So now we need to find the first problem, RAB bar dot RAB. So using the point A, 2, 5, minus 1, RA we can able to written as, so x component 2, so 2 into AX bar, plus y component 5, so plus 5 into A bar, AY bar, and z component minus 1, so it was minus AZ bar. So 1 means we cannot denote the number, because 1 into anything is the same it will give. So the second point, B, 3 minus 2, 4. So it was 3 into AX bar, that is equal to 2 into AY bar plus 4 into AZ bar. So similar way, point C. So it was minus 2, 3, 1. So the RC vector can be written as minus 2AX bar plus 3AY bar plus AZ bar. So this is the way we are able to represent RA bar, RB bar and RC bar. So now we need to identify RAB, which is equal to RB bar minus RA bar. So this formula we obtained from the previous analysis. So what is how we are able to subtract the vectors from one vector? So now we need to subtract A from B. So we need to subtract simply the components of X as well as components of Y as well as components of Z. So what is the components of X? 3 for RB and 2 for RA. So 3 minus 2 equals 1. So here the resultant vector is 1AX bar. So minus 2 minus 5. So that means minus 2 minus 5 minus 7 S4 equals minus 7 AY bar. So 4 minus of minus 1. So it will give plus 5 AZ bar. So hence it was RAB bar we identified. So which is equal to AX bar minus 7 AY bar plus 5 AZ bar. So similarly RAC bar. So here it was RC bar is minus 2 minus 3 plus 1. So minus 2 minus 2. So it will give minus 4AX bar. So 3 minus 5. So it will give minus 2AY bar and 1 minus of minus 1 it will give 2. So as a result RAC bar is equal to minus 4AX bar minus 2AY bar plus 2AZ bar. So next what we have to do, we need to dot product RAB bar with RAC bar. So for that what we need to do, so for the reference I am again taking RAB bar, RC bar. So we need to multiply the X component, Y component and Z component. Thereafter we need to add the results. So how can we able to do this? So RAB X component is 1 and RAC X component is minus 4. So that 1 into minus 4. So RAB Y component is minus 7 and RAC Y component is minus 2. So minus 7 into minus 2. So similar way 5 into 2. Those are the Z components. So what will happen? So 1 into minus 4 minus 4 minus 7 into minus 2 plus 14. 5 into 2 is 10. So it will give the result 14 minus 4 10 plus 10 20. So RAB dot RAC is equal to 20. So in this process what we did, we have 3 points. We have only 3 points. So that we need to identify two vectors. So for identifying those vectors, first we identify the small vectors. That means point vectors we identify to the RA, RB, RC. So thereafter if you want to find RAB, it will become RB minus RA. And if you want to find RAC, it will become RC minus RA. Suppose if you want to find RCA, what will be the formula? RCA means RA minus RC. Some people will remember with the suffix. In the suffix, if A first comes, they will write A second in the equation. So some people can remember like that. So this is another way to remember the formula. So next one is the angle between RAB bar and RAC bar. How we can able to identify the angle? So let us see the angle. So we know that if you know the magnitude of two vectors as well as certain angle between them, this is the dot product. But here in this case, we already know the dot product and magnitude, but we need to identify angle here, so that we can able to identify the angle. So here we know the RAB bar dot RAC bar, which is 20. But we need to identify modulus RAB bar and modulus RAC bar, so that we are able to identify cos theta r. Where theta r here is the angle between RAB and RAC. Let us assume theta r is the angle between RAB and RAC. So now we need to identify magnitudes of RAB bar and RAC. So the magnitude of RAB. So we have the vectors above. So it has the components 1, minus 7 and 5. So square root of 1 square plus minus 7 whole square plus 5 square. So it will give 1 plus 45 plus 75 and which will give square root of 75 and is equals to 8.66. You can calculate it, no problem. So the next one is RAC. So you can see the RAC vector by above. So its component is -4, -2 and +2. So -4 whole square plus -2 whole square plus 2 square. For that 4 square root. So 16 plus 4 plus 4. So square root of 24 it will give 4.89. So this is the way we are able to identify the magnitude. So now we need to multiply these two magnitudes and into cosine theta is equal to our result 20. So as a reference I write this expression again. So 20. So the result of RAB bar dot RAC is equal to 20. So the magnitude of RAB is 8.66 and the magnitude of RAC is 4.89 into cos theta. So now what we have to do? So multiply those two, which will give the result of 42.425 cos theta. So now how to take the cos theta to left hand side? So what will happen? So cos theta is equal to 20 divided by 42.425 and that is equal to 0.4714. So now theta is equal to, so cos we have to take to the right hand side, then it will become cos inverse. So cos inverse 0.4714. So by calculating this you can able to get the angle. So and this is the final angle here. So the angle between the RAB and RAC is 61.8. And you can make a statement here about. So now what we have to identify the length of the projection of RAB on RAC. The length of projection of RAB on RAC. It is nothing but finding the component, vector component. I already told you in the previous class when we discussed about this problem. So the length of projection is nothing but the vector component. So the vector component in the direction of RAB bar for RAB. So what we have to identify in the direction of RAC means the direction vector of RAC we need to identify. So what is the direction vector? So unit vector in the direction of RAC can be called as direction vector of the RAC. So first what we have to do? We need to identify the direction vector of RAC. Thereafter we need to multiply those unit vector with RAB. So first we need to identify unit vector in the direction of RAC. So let AN bar is the unit vector in the direction of RAC. Then what is AN bar? So AN bar is equal to RAC bar divided by modulus RAC bar. So RAC bar we know that minus 4x bar minus 2a bar plus 2az bar divided by modulus means the component square. So minus 4 square plus minus 2 square plus 2 square. So the bottom result will give 4.89. We already find it. So then AN bar is equal to, so minus 4 divided by 4.89 will give 0.818. So 2 divided by 4.89 will give 0.409 and the same 2 divided by 4.89 will give 0.409. So this is the unit vector in the direction of RAC. So now if you want to identify the length or vector component of RAB in the direction of AN, what we have to do? We have to dot product RAB with AN. So for that, so let us take the reference again. RAB bar is equal to x bar minus 7ay bar plus 5az bar. So now we have to make dot product between RAB and AN. So by making dot product, so the component x component for RAB is 1 and AN bar is minus 0.818. So there minus 7 here by component minus 0.409. And there the z component is 5 and here it was 0.409. So it is equal to minus 0.818 plus 7 into 0.409 will give 2.863 and 5 into 0.409 will give 2.044. So the final will be is equal to 4.089. So and this is the length of the projection of RAB on RAB. So what we did here, so on RAB means if vector, any vector on means we need to identify that vector unit vector. So we identify the AN cap, which is nothing but the unit vector in the direction of RAB. So thereafter we need to multiply that vector with respect to RAB bar. So that means here dot product. So we need to make dot product between the vector identified and as well as the vector of projection. So RAB bar dot AN bar. So this will give 4.085. So the dot product means it will give a scalar result. So that was 4.089. So the length of projection of RAB and RAB is 4.089. So like this, can make a statement after finding a result. So next we need to identify the vector projection. So if you want to identify the vector projection, so simply we need to multiply the result. What is the result? Vector component result with respect to the unit vector in the direction of RAB. So what is the result we got? So the result is 4.089. So this is the result we got. So that means this is RAB bar dot AN bar. So if you are able to multiply this result with unit vector AN cap, it will give vector projection. So RAB bar dot AN bar will give the vector projection. So that was 4.089 into the AN vector. So it will give minus 3.34 AX bar minus 1.67 AY bar plus 1.67 AZ bar. And it can be called as the vector projection of RAB bar on RAB. So this is the way we are able to identify the vector projection as well as vector components. So I already showed you by using the dot product we can able to identify the vector components. So this is also can be called as length of projection. If you want to identify the vector projection, simply you need to multiply the unit vector for the result. That means result is vector component. So vector component into the unit vector will use vector projection. Next, we need to discuss about the problem that is available in cross product. So this is the problem. This is available in cross product. You can see that. So it was a triangle defined by 3 points A, B, C we gave. So that we need to identify RAB bar cross RAC bar. Similar way, the area of the triangle and the unit vector perpendicular to the plane that contains the triangle. So here the triangle was formed by 3 points. What are those 3 points? A, B, C. So similar way in the previous model. So RAB bar we need to identify for that. RAC bar we need to identify. What is the formula for RAB? It is nothing but RB bar, small RB bar minus small RA bar. So what is the formula for RAB? Again it was small RC bar minus RA bar. So I wrote here. So RAB bar is equal to RB bar minus RA and RAC bar is equal to RC bar minus RA. Now we have to identify RAB bar from RAC. So this is the point we can able to write. So A2 minus 5 1. So it will become 2AX bar minus 5AY bar plus AZ bar. B minus 3 2 4. So it will become minus 3AX bar plus 2ay bar plus 4az bar, and thereafter C 0, 3, 1. So 0 means we need not to write that component. So 0 and everything will become 0. So 3 into ay bar plus az bar. So that we can able to identify RAB bar. So which is equal to the RB bar minus RA bar. So minus 3 minus 2 will give us minus 5. 2 minus of minus 1 will give us plus 7. And 4 minus 1 will give us 3 as bar. So this is the RAB bar. So similarly RAC bar. So 0 minus 2 will give us minus 2ax bar. So 3 minus of minus 5 will give us 8a bar. So 1 minus 1 will give us 0. So no need to write az bar. Why? Because 0 into anything 0. So RAC bar is equal to minus 2 ax bar plus 8 ay bar. So for the reference I am again taking the RAB and RAC to write the components as per the formula in vector product, which is nothing but cross product. So what is the formula for cross product? We know that. So A bar cross B bar is equal to, the first row is the unit vector, the second row is A bar component, third row is B bar component. So here in the place of A bar and B bar there are RAB bar and RAC bar. So first row is always common, A by AZ, it is rectangular coordinate system. So the next one is RAB component. What are the components? RAB minus 5, 7, 3. So it was minus 5, 7 and 3. And third one is RAC component. What are those components? Minus 2, 8, 0. So why it was 0? So there is no plus component, so it was 0. So minus 2, 8, 0. So don't forget to write 0. So if any component is not existed, we have to write that as a 0. If some cases x component will not be available, so in the place of x we need to write 0. So here in this case the z component is not available, so we have to write 0 in the place of z. So you can able to identify the determinant for this. It is easy. So we need to close. If you want to identify the product of Ax, we need to close the column of AXs as well as row of Ax. And first element will have plus sign. So plus Ax into. So we need to close the column of Ax as well as row of Ax. So 7 into 0 minus 3 into 8. So for the second element, the sign is minus into. So again the same, AY column and AY row. So that it was minus 5 into 0, 3 into minus 2. So next, we need to close the column of AZ as well as row of AZ. So that it was minus 5 into 8. 7 into minus 2. So this is the way you can able to identify the determinant. You already know it. So the next result is 7 into 0, 0 minus 24. So minus 5 into 0, 0 plus. So minus into minus plus, so it will become plus 6. So and thereafter minus 5 into 8, minus 40, minus 7 into minus 2, plus 14. And the final result is minus 24 AX bar minus 6 AY bar minus 26 AZ bar. So this is the result, RAB bar cross RAX bar. So this is the way we are able to identify cross product between any two products. Two vectors. So the next one is we need to identify the area of the triangle. So this is the application of the cross product. So I already told in the previous class, the application of the cross product is by using magnitude, we can able to identify the area of the triangle that was formed by the two vectors. So by using magnitude, so magnitude not equal to the area of the triangle. Using magnitude, you can able to identify area of the triangle. How I can see that? So let us say these are the 3 points we are having now, A, B and C. So now the vector from A to B is or AB bar, and the vector from A to C is or AC bar. So now we need to identify the triangle those are occupied by RAB bar and RAC bar. So now we need to identify this triangle area. So it needs to be identified. How can we able to identify? We need to identify this area triangle by knowing the magnitude of RAB bar. What are the two vectors here? RAB bar and RAC bar. So we need to identify the magnitude of those two vectors for the cross product. So we already find the vector RAB bar cross AC bar. So now we need to identify the magnitude. So the magnitude of RAB bar cross RAC bar is magnitude of minus 24AX bar minus 6AY bar minus 26AZ bar. We already identified it. So it will become square root of 24 square plus 6 square plus 26 square. So it will give square root of 1288. That means 1288. It will give 35.8. Now we know the magnitude. So now how we can able to identify the area of the triangle? So the magnitude divided by 2 will give area of the triangle. So what is the area of the triangle that was formed by two vectors? The magnitude of those vector cross products divided by 2. So the area of the triangle is magnitude of those vectors will give 35.88 by 2, which will give 17.94. So no need of writing units here. Why? Because they were not given any unit. So we don't know what are the units available. So just leave the units point. So 17.94. So this is the way we are able to identify the area of the triangle by using two vectors. So what is the formula for that? Magnitude of cross product of those two vectors divided by 2. So next, we need to identify a unit vector perpendicular to the plane in which the triangle is located. So let us assume the triangle is located on your screen. So that means, so you are seeing the screen also, screen also seeing you. That means the screen seeing direction is the perpendicular to the plane that contains both triangles. So your screen contains the triangle. So screen is seeing you. So in which direction it was seeing? The perpendicular to the plane that contains triangle. So now we need to identify the vector direction that is perpendicular to your plane. That means screen to your face. The vector from the screen to your face. So we need to identify that vector. So how can you identify that vector? Simply it is the unit vector of the cross product between RAB and RAC. So why? Because the triangle was formed by RAB and RAC. If you can able to identify the unit vector for that RAB cross RAC, it is the perpendicular direction vector as per the right-handed screw rule. So as we told in the yesterday's class, so what is the right-handed screw rule? If there is a vector A and there is a vector B, if an angle that was making from vector A to B, you can able to identify the direction. How can you able to identify the direction? So from A to B means clockwise. If the clockwise direction means the screw will be rotated in clockwise direction and it will go in the downward direction. It will go in the downward direction. But here in this case, the A, B is in the bottom, so anti-clockwise direction. Anti-clockwise direction means, so from the screen anti-clockwise direction, it will be the direction the screen that was seeing you. So backward direction. So anyway, so if you can able to identify the cross product unit vector, it will give the direction. Simply you need to identify the unit vector for the cross product. So let the unit vector perpendicular to the plane is AT bar. So AT represents T represents triangle. So this AT bar represents triangle direction. So AT bar is equal to cross product between RAB bar and RAC bar divided by magnitude of RAB and RAC. So simply you can able to tell, if you want to find the unit vector perpendicular to the plane that contains both RAB and RAC, so you need to identify the unit vectors for RAB and RAC. So what is the behind concept is, so the triangle seeing you. So the triangle seeing you means, that is the direction of the triangle. If you want to find the direction, you have to use right-handed rule. So right-handed rule means, what it was telling, the resultant direction is perpendicular to the plane that contains cross product vector. So that means, so if you can able to identify a unit vector for the cross product vector, it is possible to identify the surface direction. It is possible to identify the surface direction. So if you know any two vectors from a surface, so by making the cross product between those two vectors, you can able to identify the surface direction. That is the application we have to know from this example. So this is the resultant one. So we know already the RAB bar graph, RAB bar, which was minus 24x bar minus 6ay bar minus 26az bar, and already we find the magnitude also 35.88, which will give the result, and this vector can be called as the vector that is perpendicular to the plane that is the triangle located. And this is about today's class. So we can see 3D coordinate system in the next class. Thank you, dear students.